Question 1. These short questions are from different area of chemistry. A flask contains 100 grams of carbon dioxide and 120 grams of oxygen at a pressure of 50 atmospheric pressure. What is the partial pressure of the gas CO2? To find the partial pressure, first we need to find the mole. A mole, N, is equal to mass weighed over relative molecular mass. The molecular mass for carbon dioxide and oxygen need to be found from the periodic table. We add carbon and 2 oxygen together, and we add 2 oxygen together here. So for carbon dioxide and oxygen gas, we look for the mass, which we're given. These are the masses. We want to find the relative molecular mass from the periodic table, and we calculate the mole. So carbon dioxide is 110 grams, oxygen is 120 grams, and the relative molecular mass of carbon dioxide is 44 grams. 12 plus 32, that's 16 and 16. 16 plus 16 is 32, plus 12, 44. And the relative mass of oxygen gas is 16 plus 16, is 2 of them, that's 32 grams. And to find the mole, it's going to be mass over relative molecular mass. So that gives you 2.5, and that divided by that is 3.75. Now we need to find, we found the mole now, we need to find the total mole. So we have to find the total mole in the system. And total mole is mole of carbon dioxide, which is that one, plus mole of oxygen gas, which is this one, and that will be equal to 6.25. So that'll be the total mole. Now we need to find the partial pressure. This is what we're looking for. So number 3, partial pressure of carbon dioxide will be equal to mole fraction times the total pressure, which is this one here. And therefore, the mole fraction is the mole of carbon dioxide divided by the total mole, and that's the mole fraction, and times it by total pressure, which is 50, and that equals to 20. So the final answer here is 20 atmospheric pressure. Question 1b. Pure PCl5 is placed in a sealed container which is heated to 200 degrees centigrade. An equilibrium is set up. PCl5 gas in equilibrium with PCl3 gas plus Cl2 gas. Under these conditions, the Kc value equals 8 times 10 to the power minus 3 mole per decimeter cube. Equilibrium constant of PCl5 equals 0.05 mole per decimeter cube. Calculate the concentration of PCl3 and Cl2 at equilibrium. At equilibrium, this is a Kc value for that reaction, and we can write Kc equals to the concentration of PCl3 times the concentration of Cl2 divided by the concentration of PCl5. Now let's write the equation again. PCl5 in equilibrium with PCl3 plus Cl2. Initially, we have 1 mole of that and 0 mole of that and 0 mole of that. When the reaction takes place, we have X value of PCl3 produced and X value of Cl2 produced. So they're the same, which means 1 of minus X is left. And then 1 minus X left is 0.05. So that is that. And the X, we go to there, the X, we go there, and that X, we go there. And then the Kc value is that value here. So we can write the Kc value, which is that, equal to X for that times X for that, divided by 0.05 for that, which is what's left. Cross multiply, because this is over 1, that goes there, and that goes there. Therefore, X squared equal to 0.05 times that, 8 times 10 to the power minus 3. Then X will be equal to square root of that, which gives 0.02. If X is 0.02, that means the concentration of PCl3 is 0.02, and the concentration of Cl2 equals to 0.02. 1c. The electronegativities of H, C, N, and F, and the boiling points of methane, ammonia, and hydrogen fluoride are shown below. explain the difference in the boiling point of methane, ammonia, and hydrogen fluoride. So first is to find the electronegativity difference. So the difference between C and H is 2.5 minus 2.1, and that gives 0.4. The difference between N and H is 3 minus 2.1, and that gives 0.9. The difference between H and F is 4 minus 2.1, and that gives 1.9. So we can say that the greater the difference in electronegativities, the higher the boiling point. Number 2, methane is nonpolar. Methane is nonpolar with weak intermolecular forces called London forces or van der Waals forces. Ammonia has both London forces and hydrogen bonding, so more energy is needed. That's why this is higher than that. Also, hydrogen fluoride has both London forces and hydrogen bonding, but the hydrogen fluoride has or have stronger hydrogen bonding than ammonia. Therefore, the hydrogen bonding is stronger than London forces. Question 1D. Compound A has the following percentage composition by mass. Calcium 81.1%, nitrogen 18.9%. The student reacts compound A with water to form alkaline gas B and alkali C. Identify A, B, and C and write the equation for the reaction of compound A with water. First, we need to find the empirical formula, and so we write calcium and nitrogen, the percentage of calcium and the percentage of nitrogen as given. Then we write the mass of calcium from the periodic table as 40.1 grams per mole, nitrogen mass 14 grams per mole, and then we can calculate the moles, which is mass over relative molecular mass, and the mole is 2.02 and 1.35. By dividing that by that, we get that. Dividing that by that, we get this. Now we can divide everything by the smallest, which is this. So that divided by itself, we get 1, and that divided by that, we get 1.5. So that divided by itself, we get 1. And then we need to times it by 2 to get rid of this fraction or decimal. So times 2 will be 3, and times 2, 1 times 2 is 2. So the formula we're looking for is calcium subscript 3 and nitrogen subscript 2. So compound A is calcium nitride. And to then write down the equation, A will be calcium nitride plus water must give, it looks like that will give you ammonia for B, and C, calcium hydroxide. So calcium hydroxide. And then we can now balance the equation. Calcium hydroxide, here we go. So that's calcium hydroxide. Now to balance the equation, we can have calcium nitride plus water, and that gives calcium hydroxide plus ammonia. So how many calcium we have? So we have 3 calcium, so I have to put 3 here. So 3 goes there, and we now have 2 times 3 oxygen. That's oxygen there, 2 oxygen there, 2 times 3, that's 6. So we can put 6 here. And how many hydrogen we have now? We got 12. I got 3 times 2 here, that's 6. This has to be 2 here because we got 2 nitrogen here, so that has to be 2. So that would be 2, and then we have 2 times 3, that is 6 hydrogen. 6 plus 6 is 12. 2 times 6 is 12. So this is balanced. Question 1E. The structure of lactic acid is shown below. Complete the balance equation for reactions of lactic acid. Reaction with sodium carbonate. If you're reacting acid with a carbonate, you will get salt and water plus carbon dioxide. So for carbonate, you need 2 of these because you're going to get sodium carbonate here. That's what sodium carbonate is. Sodium is in group 1, so you need 2 of these because carbonate is 2 minus. So you need 2 of these. Because you need 2 of these, you're going to form the structure here with sodium, and you want 2 here because there are 2 sodiums, so you need 2 sodium, so you need 2 there. So that will be 2. Therefore, you have to have 2 of these plus carbonic acid, and the carbonic acid split into water and carbon dioxide. Water plus carbon dioxide. So that looks like it's balanced because you got 2 hydrogen here, and that's a 2 hydrogen. You got 3 oxygen here. That's 2 and 1. So that's 3 oxygens. You got 1 carbon, so that's balanced. For reaction with aluminium, well, first of all, this is the acid dissociating. It's a minus, losing H plus, and aluminium is group 3, so it will be aluminium 3 plus. You want to take the 3 and bring it down, and take a minus 1, take the 1 there and bring it there to form a compound. So that would be this compound, but you want to put 3 here, and the aluminium will be this. So acid plus metal will give you salt and hydrogen gas. Therefore, we need 3 of these plus aluminium to give that structure, which is that one, and then the aluminium plus hydrogen gas. Right. So how many hydrogen we have? 3, because we're losing that. So that's 3 times that. I've got hydrogen 2 here, so I have to do 3 over 2. Because that 2 cancels that 2, so I got the 3 now, and that's balanced. Question 1F. The ester methyl ethanoate can be synthesized by reacting a haloalkane with a carboxylate ion. The mechanism is nucleophilic substitution. Outline the mechanism for this reaction. First, we can write down the methyl ethanoate. That's the product we're forming. And we can write down the haloalkane. So that's chloromethane. And this one has difference in electronegativity, delta minus and delta plus, which means electron is drawn towards chlorine. And we need a nucleophile, and here's the nucleophile here. It has a lone pair of electrons that will attack the carbon center here. This will break with heterolytic fission. So that's nucleophilic attack and heterolytic fission, which will give our product methyl ethanoate as methyl ethanoate plus a chloride ion. That's the chloride ion.